Today we're going to be talking about the Pythagorean Theorem. This theorem allows us to find missing sides of a triangle through a special relationship that right triangles have. Let's take a look at some vocabulary. Let's take a look at our definitions. A right triangle is a triangle that has one right angle. The longest side we call the hypotenuse. It's the longest side. We label it as C in our formula, and is the side the opposite of the right angle. The legs we label A and B, and they are the sides next to the right angle, and they are the shorter sides. Let's take a look at the next one. Here's a triangle. It says to label the hypotenuse and the legs. So the legs are the two sides next to the right angle, so I'm going to label them A and B because they are next to the right angle. And I know the hypotenuse is across from the right angle, so I'm going to label that C. It doesn't necessarily matter which one you label A and B, as long as you label the two sides next to the right angle. It doesn't matter, you can switch them. Let's take a look at the next thing. So continuing talking about the parts of the right triangle, this problem says given the rectangle ABCD, list all the segments that are the hypotenuse of right triangle. So here I've got one triangle, and the right angle is down here in the corner. So when I see the right angle, I can see that line segment BD is across from the right angle, and therefore is the hypotenuse. So one of mine is BD. However, there's another right triangle that's formed right here. And when I look at that right angle and the segment that's across from it, I find that that segment is AC. Now, of course, it forms two other triangles on the opposites of these. However, the line segments for the hypotenuse are going to be the same because the triangles are just across from each other. So I don't need to draw those triangles in. So the two hypotenuses that we have here are line segment BD and line segment AC. Let's look at the next one. This says, given the rectangle FGHJ, list all the segments that are hypotenuses of a right triangle. So I want you to pause the video now, see if you can identify the three hypotenuses in this problem, and then press play again to see if you're right. How did you do? Hopefully you got FJ, JG, and FG. I outlined the three triangles here so you could see the three different line segments. Now, it's very important that when you're writing down line segments, notice how I wrote the letters with a line segment above it. That's how you should write your line segments. Don't just write two letters. You need to write two letters with the line above it to show that it's a line segment. Now let's talk about the Pythagorean Theorem itself. For all right triangles, there is a relationship between the sides and the hypotenuse. And that relationship is a squared plus b squared equals c squared. So that says that the length of a squared plus the length of b squared will equal the hypotenuse when its length is squared. And we can use this to find different things and different pieces of information about our triangle. So let's do that now. So here we have a right triangle with some boxes on the side. It says, what equations can we use for this right triangle? So I know that I'm going to use the Pythagorean Theorem. My Pythagorean Theorem is a squared plus b squared equals c squared. So if I look at box A or side A of my triangle, I can see that it has four boxes along the side of the triangle. So 4 squared is 16, and that's where these 16 boxes come from. So along B, I have 3 boxes or 3 things along the side, and 3 squared is 9, and along the hypotenuse I have 5, and 5 squared is 25. So let's take a look at our formula. So I say, because a squared plus b squared equals c squared, that 4 squared plus 3 squared equals 5 squared. Then I've got 16 plus 9 equals 25. Is that true? 4 squared is 16, 3 squared is 9, 16 plus 9 does equal 25. So I know this is a right triangle. If 16 plus 9 didn't equal 25, then I know this is not a right triangle because a squared plus b squared did not equal c squared. So we can use the Pythagorean theorem to check, is it actually a right angle, a right triangle? So let's have you practice on your own. So taking a look at this triangle in their boxes, I want you to pause the video, see if you can come up with the two equations that match this triangle. Press play again to see if you're right. How did you do? Did you find 5 squared plus 12 squared equals 13 squared? And 25 plus 144 equals 169? Great. Let's take a look at the next thing. So this says, can you form a right triangle with these lengths? So as I just talked about, if it doesn't equal a squared plus b squared equals c squared, it's not a right triangle. So let's take a look at letter A on our example side. So I have 5 millimeters, 6 millimeters, and 10 millimeters. So the first thing I needed to do is to determine which one is the hypotenuse, and that's going to be the longest side. So the longest side in this case is 10, so I know that's going to be my C. It doesn't matter which one is A and B, as long as I identify the longest side as C. So I'm going to write out my formula, a squared plus b squared equals c squared, or in this case, it's going to be 5 squared plus 6 squared equals 10 squared. So now I'm going to do some math. 5 squared is 25, 6 squared is 36, and 10 squared is 100. So 25 plus 36 equals 100. So 25 plus 36 equals 61. Is 61 equal to 100? No? Then this is not a right triangle, because 61 didn't equal 100. Let's look at example B. So in example B, I've got 15, 12, and 9. So again, I have to identify which one is C. So that's going to be the longest side, and it didn't come at the end here, but it is the longest side, so I know that C is my hypotenuse. It's not the third number, it's whichever number is the biggest or the longest. So I'm going to have 9 squared plus 12 squared equals 15 squared. 9 squared is 81, 12 squared is 144, and 15 squared is 225. 81 plus 44 is 220. 144 is 225. So does 225 equal 225? Yes. So this is a right triangle. There are two practice problems there on the side. I want you to pause the video, try those two for yourself, press play again to see if you're right. How did you do? Hopefully you found that the first one is a right triangle and the second one is not a right triangle. Let's take a look at something else. Here I have a triangle that is missing a side. It says find the value of x. It gives me 6 on one side, 8 on the other, and x is missing. So I know it's a right triangle. It's marked as such, so I can use my Pythagorean theorem to help me find the missing side. So my Pythagorean theorem is a squared plus b squared equals c squared. So I'm going to write that down. Now I need to figure out which side is missing. Now I see that the side across from the right angle is missing, so I know I'm missing my hypotenuse, or I'm missing my C. So I'm going to write out my numbers as A and B are going to be 6 and 8. So I know it's going to be 6 squared plus 8 squared is going to equal x squared. I'm going to square because I'm going to do the order of operations. My exponent is going to come before my adding. So 36 plus 64 equals x squared. Order of operations again, I'm going to add my 36 and 64. When I do that, I get 100 equals x squared. But I'm not looking for x squared, I'm looking for x. So I have to figure out what I'm going to do in order to get x squared from x squared to regular x. It's an equation, so I can do something from one side of the equation to the other. The opposite of squaring is square root. So I'm going to square root both sides of my equation. I'm going to square root the x squared side, and I'm going to square root the 100 side. When I do that, x is going to be, x squared becomes x, and 100 square rooted is going to be 10. So remember, I need to write a label. So in this case, x equals 10 centimeters. So notice I took the information that I had, and I plugged it into my formula in order to figure out what the missing side is. Let's take a look at the next one. So this one again tells us to find our missing side. However, this time I'm not missing the hypotenuse because when I draw my arrow across from the right angle, I see that 9 is there. So my hypotenuse is there and I'm missing one of the legs. I'm again going to use my formula, a squared plus b squared equals c squared, and it tells me to round to the nearest tenth. So I'm going to start by writing in the pieces that I know. I don't know a, or it could have been b, but I'm going to list it as a. X squared plus 6 squared equals 9 squared. I'm going to use the order of operations, so I'm going to be using my exponents first. X squared I don't know, so that stays x squared. 6 squared is 36, and 9 squared is 81. Right now, I'm stuck in a predicament because I can't just add x squared and 36 together. They're not like terms. So I need to solve my equation. So in order to do that, I need to start by getting rid of my constant. So the opposite of positive 36 is negative 36. So I'm going to subtract 36 on both sides of my equation, and that's going to leave me with just x squared equal to 45. Now, again, I don't want x squared. I want regular x. So I'm going to have to square root both sides of my equation. So I'm going to square root the side that has the x squared on it. I'm going to square root my 45 and I end up with x equals 6.708. But it tells me to round to the nearest tenth. So I know that the 0 is not going to cause that 7 to go up. So it's going to stay x equals 6.7 inches because I need to have a label. Great. Let's take a look at the next one. This says practice. Find the value of x and round to the nearest 10. You're going to try this one on your own. Pause the video, complete the problem, press play again to check if you are right. How did you do? Hopefully you got x equals 26.1 feet because you need to round to the nearest tenth, and that 0 is going to be causing up by the 7. Let's take a look at the next one. Practice B says find the value of x. Go ahead and try this one on your own. You're going to pause the video now, press play again to see if you are right. How'd you do? Hopefully you realize that you were looking for one of the legs and not for the hypotenuse here. And make sure that you labeled your answer with inches. Let's go to the next one. So here we have a word problem. It says Algeburg is 23 miles due south of Geomdale. Probatown is 11 miles due east of Geomdale. What is the shortest distance between Algeburg and Probatown? So it says we can draw and label a picture because we're going to have a triangle. We're going to figure out which piece is missing. So I'm going to start by drawing a line down because it says Algeburg is 23 miles due south. So I'm going to say, okay, that's 23 miles due south from Geo to Alge. Then it says that I'm going to go 11 miles due east of Geomdale. East is over here, and that's going to be 11 miles. And then I'm going to connect the two, and that's going to be Probtown there. And Probtown, we don't know the distance, so we're going to call that X. Now, my picture's not the greatest, but we're going to assume that it's the right triangle here, had I done a better job drawing. So the piece that I'm missing is the hypotenuse. So I'm going to make an equation based on the fact that I know that I'm missing my hypotenuse. So I'm going to start with 11 and 23. Plug them into my equation. So I'm going to end up with 23 squared plus 11 squared equals x squared. 23 squared is 529. 11 squared is 121 equals x squared. I'm going to add them together. And when I do that, I'm going to get 650 equals x squared. But again, I don't want x squared. I want just x. So I'm going to square root both sides of my equation. Square root the 650, square root the x squared. When I do that, I end up with x equals 25.49, but I'm going to round to the nearest tenth, so I end up with x equals 25.5 miles. Excellent. Let's take a look at the next one. This road problem, Michelle is fixing a house on the second floor of her house. The window is 18 feet high and her ladder is 20 and a half feet long. How far must she place the base of the ladder from the house? So I've got my picture of the house and I've got a ladder next to it. And I know the ladder is going to be 20.5 feet long. I know the window is 18 feet in the air, so I don't know how far it is from the house. So that's going to be my x. So in this case, I made a nice right triangle with the ladder against the house, and I'm missing one of the legs because I know the hypotenuse is across from the right angle, which is going to be the 20.5. So I know that I'm missing one of the legs. So I'm going to write an equation according to that. So I'm going to start with my x squared plus 18 squared equals 20.5 squared. I'm going to do the order of operations. I'm going to square my numbers first. So I'm going to end up with x squared plus 324 equals 420.25. Now I've got an equation, so I've got to subtract 324 from both sides. So I'm going to do that. When I subtract 420.25 minus 324, I end up with 96.25. But I don't want to know what x is. X squared is. I want to know what x is. So I'm going to square root both sides. When I do that, I end up with x equals 9.81, so on forever and ever and ever. But I'm going to round that to the nearest hundredth, and I end up with x equals 9.8 feet. All right, let's take a look at the last one. This one you're going to practice on your own. It says, Harris builds this shelf for his trophies. How long is the support beam from point A to point F? So you're looking for the support beam from point A to point F. Now, you're going to need to make a triangle, so there's two ways to do it, but I'm going to use this triangle here. This being the right angle, and you're looking for the hypotenuse. Go ahead and pause the video now, try the problem for yourself, press play again to see if you're right. Hopefully you rounded it to 35.78 inches. Now, to figure out where you got that 16 from, you should add these two 8s from the side. Together they give you one side to give you 16, and down here the base is 32 inches, so this is going to be 32 inches. Hopefully that is where you figured out your numbers from for your problem. Now you've completed the notes on Pythagorean Theorem. You can go ahead and start the trail. If you like this video, throw us a thumbs up. If you love this video, throw us a 7.